note down the statement. I will explain very clearly. All of you note down the statement, please. So parallelly, how to write the notes, then only you can understand the procedure and all those things. All of you ready with your books, pen, calculators. Please keep these things with you. Let me read out once here. A linear two-terminal active network. All of you note down statement. A linear two-terminal active network consists of independent and or dependent voltage or current sources and resistors. Can be replaced at a pair of terminals. A comma B by a single voltage source Thevenin VTH V subscript TH VTH in series with single resistance R Thevenin. In series with a single resistance R Thevenin. Later, you draw this circuit. I will redraw this one because here it is not completely visible. All of you write this statement. Later, draw this one. This is complicated or complex circuit. Network and or circuit are both are same. Network or circuit. RL is the load resistance, and these are the terminals A and B. Please note down the statement, and I will explain about this statement and theorem and all those things. Sai Kumar, completed, Amma?
Yes, sir.
Yeah. So All of you listen carefully here. In a linear two-terminal active network consisting of independent and dependent sources. So let me take one example of circuit. So all of you listen carefully here. Plus minus. Let us say a 50 volt source is there, and there is a resistance of 2 ohms, and again there is a resistance of 4 ohms, and again there is a resistance of 6 ohms. There is a resistance of 8 ohm, and there is a resistance again. For example, let us say this is the circuit, and this load is RL, which is equal to 5 ohms, 5 ohm load resistance. So let us say this is a linear two-terminal active network consisting of independent sources. Also, 50 volt source is the independent source, and in the circuit, dependent sources are not there, but the dependent sources may be also present, and the source may be voltage source or current source. Here we have taken voltage source, okay, and this is also consisting of resistors. Can be replaced at a pair of terminals. Replaced at a pair of terminals. Note down this. Replaced at a pair of terminals means these are the pair of terminals AB. These are the which terminals? Pair of terminals. Replaced at a pair of terminals AB by a single voltage source. By a single voltage source, which is Thevenin, in series with a single resistance R Thevenin. So, what the theorem says that. So suppose if we see across AB terminals, before AB terminals, we have how many resistors? 1, 2, 3, 4, and 5 resistors are there, and 50 volt source is there. So this theorem says that according to this Thevenin's theorem, whatever the circuit which is available across AB terminals can be converted into or can be replaced by Thevenin, can be replaced by a single voltage source Thevenin, a single voltage source Thevenin, and in series with the resistance R Thevenin, in series with the resistance R Thevenin, with a single resistance R Thevenin. So it is called, let us see, I am going to draw this circuit in a dotted line. So this is the circuit. This is the circuit. Listen carefully. This is the circuit here. This is called a complicated network. This is called a dotted line. This is called a black box, which represents a circuit or network. This is called a black box, which is consisting of these resistors and voltage source and all those things. A black box, and across AB terminals, this is the load resistance RL. So this complicated network can be what you call replaced by Thevenin and R Thevenin. Thevenin and R Thevenin. And this RL is remains same. RL won't be changed. So this complicated circuit can be converted into a single voltage source and single resistance. Single voltage source and a single resistance. Then you can easily calculate whenever the load is changed. Load may change in electrical engineering. The load may be changed time to time, because load is on practical, according to practical consideration, the load is turning off a fan or a tube light, and ACs, refrigerators, and all those things. So all the time you want to turn on simultaneously. So time to time the load may be varied. So at a particular time you will be having 2 ohm resistance, 2 ohm loads, and 8 ohm loads, and 6 ohm loads, like that. These loads are going to be changed, but the load is changing only across this pair of terminals, AB terminals, and whatever the circuit which is present before this pair of terminals is not changed. The circuit will not change, not changeable, is not changeable circuit. So if you are able to convert it is into a simple circuit for a value of load resistance RL equal to 2 ohms, okay, you can, if you are able to calculate Thevenin and R Thevenin first time, While calculating the current or resistance through the particular load, we will use this Thevenin and Thevenin circuit. Thevenin and Thevenin circuit you can easily calculate. That is the advantage of this Thevenin theorem, right? So we will be knowing the advantage while solving the problems one by one. Okay, so this is about the Thevenin's theorem. Okay, so we are going to convert a linear two-terminal active network consisting of these independent and resistors can be converted to Thevenin and Thevenin. And there is a procedure. There is a procedure to calculate Thevenin and Thevenin. Thevenin. So let us see what is the procedure we have to follow Thevenin and Thevenin. Okay, first point, procedure to calculate Thevenin. Procedure to calculate Thevenin. Thevenin means Thevenin voltage. Procedure to calculate the Thevenin voltage. So first step is write down. Remove the load resistance in bracket or target terminals, or target, remove the load resistance or target terminals and calculate the open circuit voltage. Sai Kumar, are you writing, Amma? Calculate the open circuit voltage.
Yes, sir.
Yeah. Good. Calculate the open circuit voltage, VOC, which is equal to Thevenin. VOC, open circuit voltage, which is equal to Thevenin. Now to remove the load resistance or target terminals and calculate the open circuit voltage, which is the Thevenin voltage. That is the procedure. How to calculate Thevenin elements? We can use any method, nodal analysis, mesh analysis, KCL, KVL, or usable procedure you can follow to solve the problem. Okay. Next one is procedure to calculate R Thevenin. Procedure to calculate R Thevenin. That is step 2. Procedure to find the R Thevenin, to calculate the R Thevenin. Once we solve a problem, then we can easily understand what is the statement and what is the procedure and all those things. Write down these statements one by one here. First, remove all independent sources and replace with their internal resistance. Write down. Remove all independent sources and replace with their internal resistance. Next, their internal resistances means if there is a, for example, if there is a voltage source is there, voltage source should be replaced by a short circuit because internal resistance is 0. For voltage source, the internal resistance R in equal to 0. So resistance 0 means it will act as a short circuit, and If there is a current source, the internal resistance is infinity. Internal resistance is infinity. So infinity means it is replaced by a open circuit. Next, looking from opened load terminals, looking from opened load terminals, AB, 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 find the R equivalent, which is nothing but R Thevenin. Looking from opened load terminals, AB, find R equivalent, which is nothing but R Thevenin. Srivarsha completed, Amma?
Yes, sir.
Yeah. So this is the procedure. Okay. Now, once if you write all those things, let us do a problem on this so that we will get clarity how to solve on all those things. Write down. Find the equivalent circuit. Write down a problem, all of you. Find the Thevenin's equivalent circuit. Write down a problem. Find the Thevenin's equivalent circuit. Thevenin's equivalent circuit means V Thevenin in series with the R Thevenin. Equivalent circuit for the network shown below, and then find current through, RL, R subscript L, for values of 2 ohm and 10 ohm. For the values of 2 ohm and 10 ohm. Draw the circuit. There is a voltage source which is having a 9 volts, and there is a resistance of 3 ohms, and there is a resistance of 6 ohms. This is a load resistance RL, which is variable, it is not fixed. All of you note down this problem. Completed, Amma?
Sir.
Now, see, across AB terminals, he is asking about find the Thevenin equivalent circuit for the network shown below. Across AB terminals, across AB terminals. That means whatever the circuit which is present in the dotted lines is going to be converted into what? Thevenin equivalent circuit, which is having V Thevenin in series with the R Thevenin across AB terminal. So you have to calculate V Thevenin and R Thevenin. I have already given the procedure to calculate V Thevenin. So step one, right? Step one, calculation of V Thevenin. Calculation of V Thevenin. Step one, calculation of V Thevenin. So can anybody read out the procedure I have given? How to find out the V Thevenin? Please, anyone? Srivastava, please read out, Amma. What are the things I have given?
Remove the load resistance or target terminal and calculate the open circuit voltage.
Very good. So you have to remove this load resistance RL. This load resistance RL you have to remove. Okay, and redraw the equivalent circuit. Redraw the if I remove it and if you redraw the circuit, how it will look like? The 9-volt source, 9-volt source, and this is 3 ohm resistor, and this is 6 ohm resistor, and this is pair of terminals A and we have separated this circuit by removing the RL. Okay, and if you remove this, it can create a open circuit across AB. This is known as a open circuit. Open circuit is known as a open circuit. So at this particular terminal, we can measure the voltage across AB. We can measure the voltage that is called open circuit voltage. So we can say voltage across AB is known as a open circuit voltage. As removal of RL creates a open circuit, it is known as a open circuit voltage. If you take a voltmeter and if you measure voltage across A and B, it will be treated as a open circuit voltage. So that is known as the open circuit voltage, which is same as V Thevenin. That means if you are able to calculate a Thevenin voltage, if you are able to calculate a Thevenin voltage across AB terminals, that will be considered as a V Thevenin. V Thevenin. So this VOC is equal to V Thevenin. Okay, now how to calculate the AB terminal voltage? So A is directly connected to this point and B is connected to this point. All of you listen carefully. We know the parallel voltages are same. At this node is same. This node and this node is same. What I am trying to say is that if you are able to calculate voltage across 6 ohm resistor, if you are able to calculate voltage across 6 ohm resistor, that is same as VAB and which is same as VOC voltage, which is same as V Thevenin voltage, which is same as V Thevenin voltage. Now we have to calculate the voltage across 6 ohm resistor. Can anybody tell me how to calculate voltage across 6 ohm resistor? By using simply a KVL. It is very simple equation. If you are able to find the current I which is flowing through the 6 ohm resistor, then 6 into I according to V equal to R into I. R into I is the voltage across 6 ohm resistor. And our aim is to calculate what? Voltage across 6 ohm resistor by using the KVL. By using KVL in this loop, write the KVL equation. Please, anybody tell me, Sai Kumar, can you tell me the KVL equation Amma, in the simple circuit? Srivarsha? In this loop, please tell me KVL equation.
-9
Very good. -9
plus 3I1
3I1 or I as a simple single loop, let us say I 3I
plus 6
6I equal to
0.
0. That implies 9I equal to 9 Then what is the I here? 1 ampere. So 1 ampere current, the current which is flowing through this is I equal to 1 ampere current is flowing, and current is not flowing through this one because it is a open. In a open circuit, current will not flow. There is no chance of flowing current through this one because it is open. I already said that to flow a current in a particular electrical circuit or network, there should be a closed path. If the closed path is not available, current may not flow. So as entire current is flowing through the 3 ohm and 6 ohm, then 1 ampere current is flowing here. 1 ampere current is flowing means what is the voltage across 6 ohm resistor? R into I now. What is the R value? 6. What is the I value? 1. 6 volts. 6 volts is the voltage across 6 ohm resistor, which is same as VAB, and that is called a open circuit voltage, which is same as V Thevenin. Okay. Open circuit voltage is equal to a Thevenin voltage. So finally, what is the V Thevenin here? V Thevenin equal to 6 volts. So we have calculated V Thevenin by using the procedure. All of you note down it. We will get 2 minutes of time. Please note down, and later I will explain how to calculate R Thevenin. So anybody have any doubts, you can ask here and you can clarify your doubts. Ranjit following Amma 106.
Yes, sir.
Samuel Paul 135. Uday, I hope everybody is following. Note down, please note down this problem. Later I will explain how to calculate R Thevenin. By practicing more number of problems, you will get more clarity. As it is a beginning classes, you may get some doubts. If you have any doubts, you can ask. Ranjit completed, Amma?
Yes, sir.
Yeah. Now, next one, calculation of R Thevenin. Take a same problem and we are going to calculate the R Thevenin. Because Thevenin equivalent circuit is what? V Thevenin in series with the R Thevenin. Now, calculation of R Thevenin. Okay. So let me take again the same circuit here, because we have to draw an equivalent circuit, 9 volt source, and this is 3 ohm resistance, and this is 6 ohm resistance, and these are the pair of terminals A, B's. This is A and this is B, and this is the load resistance RF. This is circuit here you have given. So for calculation of R Thevenin, you have to draw an equivalent circuit. Equivalent circuit to find the R Thevenin. R Thevenin is Thevenin resistance. In bracket, Thevenin's resistance. Now, can anybody read out the procedure here, which I have given? Because we have to follow the procedure so that we can easily understand. Srivarsha, please read out the procedure once, step by step.
Remove all the independent sources and replace with their internal resistance. Looking from
Okay.
the open load terminals AB, find R equivalent, which is nothing but R.
Thevenin, R Thevenin, RTH, R subscript to TH, R Thevenin resistance. See here, if you want to calculate the resistance, the circuit is having only a resistors. Voltage source should not be present and current should not be present. And the voltage sources and current sources are replaced by their internal resistance. As there is a, here also you have to remove the load resistance, first point you have to remove the load resistance also, and you have to replace the independent sources by their internal resistance, as it is a voltage source, and voltage sources are replaced by, please respond, voltage sources are replaced by whom? Open circuit or short circuit? A short circuit. So now remove this 9 volt source and make it as a short. This is actually removal of 9 volts creates a open circuit. Then we are going to short that. Short means a wire connection, a simple connecting the two terminals, which offers the zero resistance, and the 3 ohm and the 6 ohm. Here also you have to remove the load resistance across AB terminals. So A, B. Now Thevenin equivalent resistance is what? Nothing but the resistance, equivalent resistance seen by AB terminals. RAB is same as a V Thevenin. RAB voltage is same as V Thevenin. So this is the equivalent circuit to be drawn for calculation of the Thevenin voltage, so Thevenin resistance. Thevenin resistance have to replace the independent sources by their internal resistance and the removal of load resistance also. Now see from this side and calculate RAB. Now, if you imagine current is flowing in this fashion, and at this particular point, current is going to be divided through, some portion of the current is flowing through the 3 ohm and some portion of the current is flowing through the 6 ohm resistor. Then, what is the connection between 3 ohm and 6 ohm? You have to see from this side, not in this mesh. See from this side. See from this side. Now, can you tell me what type of the connection is there between 3 ohm and 6 ohm resistor? Can anybody tell me, please? These two are connected in series or parallel? That is my question.
Series.
So I have given a what you call a point series for series connection. The current should be same, right? But the current is going to be divided. Don't see in this mistake here. It is a, suppose if yeah, 3 ohm, suppose this is a 3 ohm and this is a 2 ohm. For example, this is the circuit A and B. If there is a current I, the same current is flowing, then we can say these two resistors are connected in series because the same current. But if you see from this terminals AB, current is going to be divided. This is one path and this is another path. Or you can draw a, at this particular point, you can draw the circuit in different fashion. 3 ohm and 6 ohm, and this is AB. Okay. In this case, the current is not same. Some portion of the current is flowing. Suppose if there is a 10 ampere current, this 10 ampere current is going to be divided. Divide means we can say these two resistors are connected in parallel. That is the difference between series and parallel. Same current is flowing through the 2 ohm and 3 ohm. Then we can say these are in series. But current is going to be divided. So here we can say that 3 ohm resistor is in parallel with the 3 ohm resistor is in parallel with 6 ohm resistor. Then what is the equivalent here? Equivalent is what? RAB equal to 3 into 6 by 3 plus 6, 18 by 9, which is equal to 2 ohms, which is same as R Thevenin. Which is same as R Thevenin. Okay, so please note down, and so you please practice more number of problems on equivalent resistance. We have done so many problems on this equivalent resistance. All of you note down this one. Sai Kumar completed, Amma?
Yes, sir.
Yeah. Now you have to draw an equivalent circuit here. Equivalent circuit of Thevenin, which is consisting of V Thevenin in series with the R Thevenin. In first step, you have calculated V Thevenin, and in second case, you have calculated R Thevenin. Now, the pair of terminals A B are replaced by V Thevenin and R Thevenin. Again, let me draw the circuit so that you can easily understand here. The circuit is like this, 9 volts, and this is 3 ohm resistor, and this is a 6 ohm resistor. These are the pair of terminals, and this is a load resistance RL. Now this entire circuit across AB terminals is replaced by whom? V Thevenin and R Thevenin. V Thevenin in series with the R Thevenin. V Thevenin in series with the R Thevenin across AB terminals. What is the Thevenin voltage? Sai Kumar, what is the Thevenin voltage which you have calculated? Srivarsha?
6, sir.
6 volts, very good. R Thevenin?
2 ohms.
2 ohms. Yeah, this is called a Thevenin equivalent circuit. Thevenin's equivalent. This is called a Thevenin's equivalent circuit. So this entire circuit, this 9 volts, 3 ohms, and 6 ohm, as it is a simple circuit, we can solve easily. Sometimes they may use another resistor is connected here, like that. They will make complicated circuit. At that time, we can save your time for calculation of current through this load resistance for number of values. Okay. Now, so previously we have removed this RL, right? For calculation of V Thevenin and R Thevenin. Now reconnect it. Okay. for calculation of the current, and he is asking about the current I when RL equal to how much? When RL equal to, first case, what is the RL value? 2 ohm resistance. When RL equal to 2 ohm resistance, calculate the current I. This symbol means variable arm. The resistance of RL is going to be variable symbol, arrow. Over a resistor, if you draw an arrow, that represents a variable resistance. Please make a note of it. Yeah. Now, what is the current I which is flowing through this one? Again, you have to write the KVL, or you can also directly calculate. So by KVL in this loop, minus 6I, let us say current I is flowing, minus 6I, and R Thevenin is 2I plus this is resistance of 2I, which is equal to 0. 4I equal to 6 volts, I equal to 6 by 4 and 3 by 2, which is equal to 1.5 amperes. So I equal to 1.5 amperes. That is the current which is flowing through the 2 ohm resistor. Okay, na? Note down this. Now, calculate the current if the resistance is, what is the resistance is given? 10 ohms. If RL equal to 10 ohms, calculate the current here and tell me the answer. Srivasa, are you doing, Amma?
Yes, sir.
Tell me the answer for RL equal to 10 ohms.
0.5.
0.5. Let me check here. Simply, just I equal to V by R. Directly also you can calculate I equal to V by R. As these two are connected in series, 6 by R is, these are series means 12. ఎంత వస్తుందమ్మా 2 plus 10 కదా 2 plus 10 6 by 12 0.5
Yes, sir.
yeah 0.5 amperes. No, the advantage with this theorem is that no need to calculate again the equivalent circuit. Every time if the load is changed for some time, then no need to calculate again entire calculations. Once if you are able to find out the Thevenin equivalent circuit, it look like a very simple circuit, then no need to again go to recalculations. Entire circuit, no need to solve the entire circuit. That is the advantage of this Thevenin's theorem. Okay, I hope everybody is following, and if anybody have any doubts, you can ask here. Otherwise, I will give another problem and we can solve this problem. Find the voltage across 2 ohm resistor. Write down the problem. Find the voltage across 2 ohm resistor by using Thevenin's theorem. by using Thevenin's theorem. In the following circuit. In the following circuit. And draw the circuit here. A 30 volt source is there. 30 volts. 12 ohm resistor. 6 ohm resistor. 4 ohm resistor. And these are the pair of terminals A and B. This is 2 ohm resistor, and he wants to calculate V across this 2 ohm resistor, voltage across this 2 ohm resistor. All of you listen carefully here. I am going to calculate Thevenin here. Calculation of Thevenin first step. Calculation of Thevenin. So for that you have to remove this 2 ohm resistor. This is called a target element because you have to calculate voltage across this. So you have to remove it. You remove it and draw an equivalent circuit. If you draw equivalent circuit, it will look like this: plus 30 and 12 ohm and 6 ohm, and this is 4 ohm. These are the terminals A and B. Okay. Now, what is the Thevenin voltage? Voltage across VAB is same as Thevenin. Same as Thevenin. Now, can anybody tell me, as it is a open circuit, what is the current flowing through this 4 ohm resistor? Please respond. What is the current flow through this 4 ohm resistor in the circuit, as it is a open range? Can you tell me, Amma?
Yes, sir.
As there is a in the current flow to the branch, to this branch, there is a open circuit. Srivarsha, will the current flow from 4 ohm branch here? Yeah, current requires two things. One is a source should be there. Another one is closed path is there. Or open circuit should not be there. As there is open circuit, current cannot flow. As the current cannot flow here, so the entire current is flowing through this. Sorry, the entire current is flowing through this loop. Okay, so the current which is flowing through this 4 ohm resistor is 0. Then the drop is also 0. Voltage across this 4 ohm is also 0 because R into I, current is 0 means voltage is also 0. So what I am trying to say is that voltage across AB is same as voltage across 6 ohm resistor. Voltage across 6 ohm resistor is same as voltage across AB, which is equal to open circuit voltage, which is known as a Thevenin voltage. Now, how to calculate the voltage across 6 ohm resistor? Once you know the current, and you can calculate the voltage here. So that is equal to minus by KVL in this load by KVL minus 30 plus 12I plus 6I equal to 0. So which is equal to 18I equal to 30, then I equal to 30 by 18. What is this value? 30 by 80. Amma? 1.66 amperes. Okay. So as you have got a current I, then voltage across 6 ohm resistor equal to R into I. So R is 6 ohm, current I is, we know current 1.66. Then what is the voltage? Please multiply and tell me. 6 into 1.66.
9.96.
9,
9.96.
9.9, 96, which is approximately equal to 10 volts. Okay, na? So as voltage across this one is 9.66, as there is no drop in the 4 ohm resistor because of the open circuit, the voltage across AB is same as voltage across 6 ohm resistor, voltage across 6 ohm resistor voltage AB. So VAB voltage means V Thevenin voltage. V Thevenin voltage. Okay, na? So we got a Thevenin voltage. Now calculate the Thevenin resistance. Meanwhile, I will take the attendance. Please tell me, calculate and tell me the Thevenin voltage here. Now, Thevenin resistance. Roll number 1. Please respond to roll calls. 1, absent. 2. Meanwhile, calculate the R Thevenin. 2, absent. 3,
Present, sir.
4,
Present, sir.
4, 4 present. Okay. Bhargav. 5,
Present,
Sai
sir.
Kumar. 6,
Present, sir.
7, 7 absent. 8,
Present, sir.
9.
Sir, 101 present, sir.
Okay, Praveen. 9, 9 absent. 10, 10 absent. 11, 12,
12 present, sir.
13, 13 absent. 14, 15, 15 absent. 16, 17, 18, 14, 15, 16, 17, 19, 20, 21, 22,
Present, sir. 22.
20, okay, 23,
Present, sir.
24, 24 absent. 25, 26,
Present, sir.
27, 27 absent. 28,
Present, sir.
okay, 9, absent. 30,
Present,
31,
Present, sir.
32, 33, 34,
Present, sir.
33 present, I think so, Bharat Reddy. 35,
Present, sir.
37,
Sir, 36 present, sir.
37, 38, 39, 40, 41, 42, 43,
Present, sir.
44, 45, 20 series. Don't leave the class. 20 series. 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
3 absent, 4,
Present, sir.
3 present, sir.
okay, 4,
Present, sir.
Akash, 5, 5, 6,
Present, sir.
7,
Present, sir.
8.
Present, sir.
Only 5 is absent from LE. Regular series 2, 7, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 21, 22, 24, 25, 27, 29, 32, 37, 38, 39, 40, 41, 42, 43 are the absentees. Anybody else for 18 series? 18 series. So this is the attendance for today's session. And what is the R Thevenin? Can anybody tell me R Thevenin? Srivasha, did you calculate, Amma? చేశారు అట్లీస్ట్ ట్రై చేశారా? For R Thevenin, see, all of you listen carefully. For R Thevenin, you have to remove the load resistance, and voltage source is replaced by which circuit? Voltage, yeah, short circuit. So it is replaced by a short circuit. Now see from this side and calculate R Thevenin. Now if see from this side, this 4 ohm resistor is directly connected to AB, and what about this 12 and 6? How they are connected? At this particular point, current is going to be divided. As the current is divided, then this 12 is parallel with the 6. Calculate the 12 in parallel with the 6.
4, sir.
12 into 6 by entama?
4 ohms.
4,
Yes, sir.
12 plus 6, which equal to 4 ohms. Now, if you replace with the 4 ohms, and this 4 ohm resistor is, if you redraw the circuit again here, put Thevenin 9.96. This is 4 ohm resistance, and this is 4 ohm resistance across this AB. See from this AB side, how these 4 and 4 are connected? Series. So RAB equal to 4 plus 4, which is equal to 8 ohm. Now we got Thevenin and R Thevenin. Let us draw an equivalent. When will be the next class? I think it will be at 2 o'clock, right? Plus and minus. Thevenin is how much? 9.96 volts. R Thevenin is 8 ohm. And reconnect this is called the Thevenin equivalent circuit. Reconnect what is the load resistance value, Amma? What is the value of resistance which you have removed earlier? 2 ohm. And we have to calculate voltage across this 2 ohm resistor. How to calculate? First calculate the current in this one. For that you have to write KVL. But minus 9.96 plus 8I plus 2I, which is equal to 0. So 10I equal to 9.96. What will be the I? 9.96 by 9.96 by 0.996. Once if you get the current I, then what is the voltage here? R into I, which is equal to R is 2 and I is 0.996. What is the value of it? 1.992. So that is the voltage across this 2 ohm resistor. So in this way, you have to solve these problems. I hope everything is clear to everyone. If anybody have any doubts, you can ask. Otherwise, you may leave. The class is finished. But the thing is that you have to practice more number of the problems based on this.